Every single day, there is an invisible war being waged for your consciousness. And most of us are completely unaware that it's even happening. Yet, this hidden battle dictates your energy, your mood, your cognitive performance, and ultimately, how you age. Today, we're diving completely beneath the surface. In this explainer, we aren't just looking at isolated health habits. We're going to uncover the hidden biological operating system running your entire body. And to do it, we're going to use one of the most universal, yet deeply misunderstood human behaviors as our lens. We're talking about the daytime nap.
Let's dive right into this, because we are faced with a pretty profound scientific paradox here. According to the literature, a perfectly timed 20 to 30-minute nap acts as an absolute cognitive supercharger. It sharpens your focus, boosts your memory, and actually regulates your nervous system. But if you cross a specific threshold, say stretching that nap to 60 or 90 minutes every day, the data violently flips. Suddenly, chronic napping is heavily linked to severe cardiovascular hazards, systemic inflammation, and even early neurodegenerative decline. So how on earth can the exact same behavior be both a biological enhancer and a glaring biological warning sign? Well, the answer lies in the invisible architecture of your brain.
To really understand this paradox, we first have to look at the two biological systems that are essentially fighting over your state of mind every single second you're awake. Scientists call them Process S and Process C. Process S is your homeostatic sleep drive. Think of it as this mounting physical pressure to sleep that builds up every minute you keep your eyes open. On the other hand, Process C is your endogenous circadian rhythm. That's the 24-hour internal clock governed deep within your hypothalamus, constantly sending out signals to keep you alert. Your long-term health is largely determined by how well these two invisible processes harmonize with one another.
Now, the specific neurochemical driving all that homeostatic sleep pressure is a molecule called adenosine. Every single time your cells burn energy, they produce adenosine as a byproduct. I want you to visualize adenosine like a neurochemical hourglass. As the sand accumulates over, say, 16 to 18 hours of wakefulness, it physically binds to receptors in your brain. It's essentially putting earplugs on your wake-promoting neurons. It literally forces your nervous system into fatigue. So by the time the early afternoon rolls around, your brain is absolutely swimming in it.
And right when your adenosine levels are peaking, your internal circadian clock, Process C, experiences a built-in temporary dip in alertness. For most of us, this happens typically between 1 p.m. and 3 p.m. Here is the absolutely crucial takeaway. Feeling tired in the early afternoon is not a design flaw, and it's definitely not a sign of weakness. Evolutionary biologists actually view this post-lunch dip as a remnant of biphasic sleep patterns. It is literally the perfect biological window to rapidly clear out that accumulated adenosine without ruining your ability to sleep later that night.
So what exactly happens on a microscopic level when we close our eyes and give in to that afternoon dip? Well, sleep isn't just a simple off switch. It's an active, multi-stage relay. We transition through a light stage 1, drop into stage 2 for about 10 to 25 minutes, and then if we stay asleep, we plummet into the deep, slow-wave sleep of stage 3 and eventually hit REM. But for the purpose of a highly optimized daytime nap, stage 2 is our primary target, because within this specific window, the brain performs an astonishing mechanical feat.
Recent neuroscientific research has actually isolated specific bursts of electrical activity during this stage 2 window. They're called sleep spindles. But not just any spindles, specifically slow spindles grouped into tight clusters occurring right over the frontal cortices of your brain. When you take a short nap, these spindle trains act like biological wiring mechanisms. They are actively reactivating and consolidating the data you absorbed earlier in the morning. They literally take fragile short-term memories and physically wire them into long-term storage.
So a perfectly timed 30-minute nap isn't laziness. Far from it. It is a highly evolved strategic biological tool. By stopping at 30 minutes, you clear out the adenosine, you refresh your alertness, and you trigger those frontal spindle trains to encode memory, all without altering your core circadian rhythm. You are essentially pressing save on your brain's hard drive while simultaneously recharging the battery.
However, this brings us to the dark side of our paradox. We've seen the incredible cognitive enhancement of the micronap, but what happens to the body when we bypass that 30-minute mark? What happens when a nap stretches to an hour or even 2 hours, day after day? Well, the underlying biology violently shifts. It goes from recovery to a state of profound physiological confusion.
The immediate consequence of crossing the 30-minute threshold is that you enter the danger zone of stage 3 sleep. That's your deep, slow-wave sleep. Waking up from this stage results in a phenomenon called sleep inertia. Because your brain's metabolism and blood flow have drastically slowed down, forcibly waking up leaves you with that intense, heavy grogginess that can last for hours.
Your brain is desperately struggling to reboot. But listen, that short-term grogginess, it's just a whisper of the real problem. The long-term epidemiological data is where things get truly staggering.
A landmark 18-year study from the Karolinska Institute found a massive 47% increase in cardiovascular disease risk for individuals who sleep under 7 hours a night but routinely nap over 30 minutes a day. And even for normal sleepers, napping longer than 30 minutes increased cardiovascular risk by 23%. Let that sink in for a second. Just an extra 20 minutes of daytime sleeping drastically alters your long-term heart health.
When we compare the internal environments of short naps versus long naps, the mechanism really becomes clear. Chronic, prolonged napping fundamentally disrupts your nervous system's regulation. It drives abnormal, erratic fluctuations in your 24-hour blood pressure, which slowly damages your blood vessels over time. It's linked to an increased risk of atrial fibrillation, and it drives chronic, low-grade systemic inflammation. The body is essentially caught in this weird twilight state, unable to fully engage in the deep repair of nighttime sleep, yet unable to remain optimally alert during the day.
But the cardiovascular risk still doesn't fully explain the paradox, does it? The most startling connection in recent medical research isn't just about the heart, it's actually about the aging brain. Why does excessive daytime sleepiness and a sudden reliance on long naps serve as one of the strongest early predictors of Alzheimer's disease? What exactly is happening on a cellular level?
The answer lies in structural brain pathology. Research out of Washington University reveals that before cognitive decline is even noticeable to a patient, toxic proteins called tau tangles begin to accumulate in the brainstem's arousal centers. Now, this accumulation physically damages the delicate neural networks responsible for generating deep, slow waves during your nighttime sleep. And because those slow waves are damaged, the brain's glymphatic system, which is basically its overnight metabolic waste clearance system, absolutely plummets. Your brain literally loses the ability to wash itself at night.
And this creates an insidious, self-perpetuating cycle. First, tau pathology quietly damages the sleep centers. Second, because of this physical damage, nighttime sleep becomes profoundly unrefreshing, even if the person is in bed for a full 8 hours. Third, because they aren't getting actual restorative sleep, their daytime sleepiness skyrockets. And finally, they're forced to take longer and longer daytime naps just to compensate. But because their slow wave generation is structurally broken, these long naps offer zero biological restoration. The early brain damage is tragically masquerading as simple daytime fatigue.
Which brings us to a total paradigm shift. Health is not a collection of separate, isolated habits. Your daytime energy, your cardiovascular health, your systemic inflammation, and your cognitive aging, they are not separate tracks. They are a single, continuous, tightly interconnected biological loop. The way you manage your adenosine levels at 2 p.m. directly influences your nervous system, which dictates your inflammation, which literally shapes how your brain ages decades from now.
It proves how a seemingly trivial biological input, like the duration of an afternoon nap, cascades into profound long-term outcomes. A 20-minute nap engages spindle trains and enhances your memory. A nap creeping past 60 minutes triggers blood pressure variability and spikes your cardiovascular risk. And an underlying pathology like tau accumulation manifests as a disruption in sleep architecture, silently robbing you of metabolic waste clearance. Every choice you make, every environment you put your body in is constantly feeding data into this systemic loop.
Which leaves us with this final, profound realization. The invisible forces of adenosine, circadian rhythms, and cellular repair are writing the story of your aging every single time you close your eyes. Your body is an extraordinarily intelligent, deeply interconnected system. It is constantly communicating with you, whether through the brilliant cognitive boost of a short rest or the blaring warning sign of chronic daytime exhaustion. The real question is, now that you hold the keys to this underlying operating system, how are you going to use it to program your future?